Okay. Hello, everyone. We are going to start recording. We are going to demonstrate how to resolve a question on the common emitter amplifier. And this is the amplifier we are going to resolve. And your name?
It's okay.
Yeah.
You're just gonna solve this question with a student.
Yeah. Okay. So you are going to demonstrate to us how this question is resolved. The question has several parts. So this is the amplifier, so-called common emitter amplifier. It has an input Vs and it has an output Vout. The first question is to find the DC voltages at the base, emitter, and collector. And with the IC, with the collector current, then the next question is to find GM, RPI, and analog log. And we are going to use the small signal equivalent circuits to find the voltage gain Vout over Vin. And finally, we will try to uh, find the voltage gain again without the early effects. And then we will compare the percentage error. So this is the question. Yeah. Now suppose, so shall we start?
Yeah.
Yeah, okay. So we are going to start it.
You turn off your screen share, right?
Yes.
Stop sharing the screen.
Okay. So your turn. Yeah, just try to solve the problem.
We use DC biasing first, right?
Yes. Correct. So this is part A of the question. Yeah. Let's see the thing with part A. Okay. First, we need to find. I think the very first thing we need to do is to find uh, the collector current. The collector current, you can see that the IE here is 1 milliamp, similar to the previous question.
So I have to do the DC biasing first, and then I will try to find.
No. I think my suggestion is just follow the exact principle of the previous question. We have IG here.
Okay.
IE is very approximately equal to IC. So IC, write down IC is going to be 1 milliamp. Yeah. Do you agree that IE is 1 milliamp? And previously, you have already calculated IC is equal to beta 1.
Okay. Okay.
And beta 100. And 1 plus 100. And 1 milli. Yeah. So you can calculate the value. Actually, you don't even need to calculate it.
Why?
1 milli. Yeah, 0.99. 0.99.
10.
Yeah.
9.9 multiplied with 10 power minus 4.
Yeah, this means 0.99 milli.
Okay.
Okay?
Milliampere.
So, okay, good. So we found the value of IC. Then the next thing that we can work out is the collector voltage. Yeah, just write down the equation for the collector voltage. I mean the voltage here, VC.
VCC minus RC multiplied with I0.
Exactly. Exactly. Yeah. All right. Milli. So I'm going to do a calculation for you. 10 minus
AK
AK
of 1.99 milli.
0.99 milli. Yeah, 2 volts.
2.08.
We don't need to be exact, just 2. Okay, good. So we got the first answer, correct? Yeah, 2, yeah. The answer, if you remember the question, yeah, the first answer, yeah, 2 volts. Okay, now we are going to.
So we have finished the question A, right?
No, we have to find emitter voltage as well, not just the collector voltage and the base voltage.
VE, right?
This one we see now we are
I
going.
know if the emitter voltage is VE, right?
Yeah. So what is it?
I just want to write down so that I could remember.
And also VB. VB.
Base. And collector, right?
Yes.
And VC.
Yeah. Okay.
So we have VC already.
Done. Yeah. Now and we are going to find VB. And
We
how?
should take the picture first.
Yeah. You don't need to take the
Yeah,
picture.
it should be in the picture so that I can see it at home as soon as I want.
Okay. Now you have already calculated the voltage here. We see. And the voltage for now in this circuit, first of all, if you are dealing with DC biasing, then the capacitor is going to be open circuit.
So now we do the DC biasing.
Yeah, we are still in question A. Now you have a voltage here. VCC equal to 10 volt. You have 1 milliamp here.
I see.
And this one is also 1 milliamp.
199.
No, IC is this value, but I'm going to do approximation.
Okay.
There's no need to be exact. But this one is 1 milliamp.
So we can be write out here is approximately 1 milliampere.
Yeah. Okay? So 1 milliamp. Now,
They have different. So it's not approximate. The I is exactly 1 million.
yeah. This one is recording and start. Huh? Okay,
Yeah,
good.
yeah, it's this.
Now we don't need to consider this part because
Yeah,
the open circuit.
Yeah, yeah.
So we have to do this.
So we omit the capacitor, and then this will be on the wire.
Yeah. So this is IP, and the resistor here is
10K RB.
10K,
It should be with RB.
RP
This is
10K.
way RB.
Okay. So now our job is to find this voltage. Okay? Our job is to find this voltage. Now, your turn. What is this voltage?
EV, right? EV is
Is the base current times this one. Okay?
I will multiply the RB.
Yeah. Maybe okay. And how to calculate IP?
Use
Correct, correct. So IC divided by beta. And
RB is a 10K.
yeah, 10K. Okay?
If I see is approximately
1 million.
1 million. Over there is 100.
100.
10K.
Okay, I'm going to do the calculation. I'm going to do the calculation. 0 point divided by 100 times 0.1. But before going forward, this voltage is pointing, you have to remember the voltage
The
pointing downward.
opposite direction with the current.
Yeah. So VB will be negative. Yeah. Correct. Correct. So now the
So 11.1.
on one. So now do you agree your answer is consistent with the given answer? Okay?
And I take a picture.
Yes.
Okay.
Now, the next thing that we are looking for is um, the emitter voltage, VB, VE. And how are we going to find VE?
Is it some kind of current source?
No. You don't need to look that far.
Why?
You forget about the current source. We just look at here. And what is the value for the VBE?
0.7
0.7. And VB, what is the power? You have already calculated VB.
minus.
Yeah. So can you calculate VE based on the value of VB? Yeah, do it.
E based on
VB.
VB minus 0.7.
Correct. Please.
Should I use English?
Okay. Well, what does it mean?
The opposite direction with IV.
Okay, well,
But I thought English is longer, so I use Vietnamese.
We, ye. Oh, 0.7. Yeah. Write it down. 0.7. Correct. 0.7. Okay. Now,
It's just VBE, right?
VBE.
VBE.
Okay, continue. VBE is minus 0.1. Yeah. Minus 0.1. Okay?
Okay.
So,
So minus 0.3 volt.
correct. So now let's check the answer. Do you agree with me? You got the answer right now. Okay? Okay, now the first part of the question has been done. The first part of the question, the DC biasing is done. So,
So take a picture.
yeah. So shall we go ahead? Shall we go forward? We are dealing with part B of the question.
Okay, sorry. So we'll erase this.
Yeah, we can erase it. Yeah, we'll have you. We erase it. Let me do it. Let me do it. It's more convenient for me to do. Now the next part, yeah, it's okay. Don't worry. The next part of the question is to find the AC parameter, GM. So GM.
We still need the beta and the VA here, right?
Uh,
Do we need it in the question B? The beta and the VA?
no,
No?
we only need the IC.
Okay.
But IC is already given. IC.
So 1 milliampere.
Okay. And VA, we need to know.
Usually approximately. So less confusing.
Okay. You want to be exact. GM and then alpha.
I mean, I'm not.
I don't know. Okay, your turn. Do you want a black pen?
What?
Do you want a black pen?
No, so we speed it. So we use, I have to convert it into the pi model.
No.
No?
Do it now.
Just jump right in the calculation.
Yeah. GM is equal to what?
Let me check right now.
IC divided by VT. Divided by 0.026. So, yes, you do a calculation. Should be 0.4. Okay, done. So your answer is exactly the same as the given answer. Okay? And the next thing is R pi. You remember how the formula for R pi? Beta divided by GM. Okay, yeah. Your handwriting is very helpful.
I have a big handwriting.
Yeah.
It's easy for me to see because my
And also
eyes are so
is,
good.
yeah, also
And
in the
Arnold, right? Then we move to Arnold.
I don't know, yeah.
VA over IC.
VA is 100. I need to move a little bit further because 100K. Good, perfect. So question B has been dealt with, and the answer is exactly. You're 2.5K, yeah, correct, all
Also,
correct.
so this is the unit for the GM.
Yeah. Uniform here, we don't worry about that. Nobody
I
care.
care about.
We,
Sometimes I have
yeah,
question with the unit.
okay, done.
And I take picture.
Good job.
Okay.
Okay, now,
Then we
the
move to
first
C.
question, move to question C.
Sorry, erase it.
Erase it, and then we are looking for, yeah, I can move a little bit forward now. Okay, good. Yeah, let me just grab the black pen. Black pen is clear. It's easy. Okay?
To right.
No, no, it's okay, yeah. Yeah, you just draw the. Yeah, okay, okay. Yeah, you should. Okay, done. Uh, here, we can use background is clear. Now, we can, uh, first of all, we just substitute the transistor with pi model.
Experience or the skin.
Yeah, unfortunately. Yeah,
So I draw first, right?
AV, sorry, not VA. VA is this one.
Okay.
AV.
Okay.
Okay, now please draw this.
Easy lesson.
No, this is biasing. This
Maybe because it's this pi model.
pi model. We just substitute this with pi model.
This is one only. So we still draw the
Draw this
capacitor.
first and then draw the peripheral resistance. Yeah, just draw the pi model here in the
So
middle.
this is AC analysis, but we just keep the original and we convert it into pi model.
We convert it into pi model first. I will guide you how to do it. Just write down the pi model. Yeah, in the middle. Yeah. Yeah.
Sorry.
Yeah. The pi. I don't know. Okay. Okay, done. Now, right, the next step. So if you look at the reciprocation, our first step is to short circuit solar capacitor.
So this is AC analysis.
Yeah. We short circuited.
We should write AC analysis.
Yeah. AC analysis. Okay, continue. Yeah. First, you.
Starting room.
Yeah.
The short circuit.
Yeah.
So,
RP. Short circuit.
Equal to RS, right?
Yes.
Will we still have this one?
Yeah. Write it down. We don't need it, but we'll do it later. Okay? Yeah. Yeah. Good enough. And also the C terminal is connected to RC and then to AC ground.
Hold it.
Yeah. RC. RC is AK. Okay? My handwriting is not harsh, Yeah, it's better to be. Okay. Okay? And the C terminal is also connected through a capacitor to RL, the load, right? So you do it. You know what what we are dealing with.
Right?
Yeah. Okay. Correct. And then correct. The this is VR. Okay. Uh, do you remember the value we are calling
move in this way or this way.
the current?
And the direction of the VL.
Yeah, move over. And we will deal with this later. Yeah, the current IL. Yeah, I know what, but we will do this. I know is equal to minus VL times the resistance.
Okay.
All the resistance. We will do it later. Okay. Now basically we almost finished the equivalent circuit. Uh, I think we have already finished the equivalent circuit. And more importantly, the E terminal of the transistor
Connect
is
to the
to the
ground.
Okay, so connect to the ground. Okay, so this is connected to the ground, this one is connected to the ground, and this one is connected to the ground. Okay, we have almost done numbers. What we are looking for is the voltage gain. We can use the same method. We can use the same method as we did before. We only focus on this part. So we are, first of all, we write down the expression for IL. IL is equal to, why IL can be expressed in terms of
VL.
alpha voltage.
VL over RL.
Yeah.
Okay.
Yeah.
So RL is around here.
So you can do write down one equation first. And another equation is IL can also be expressed in terms of T. VO, not VO.
RL.
RO now in parallel with RC, in parallel with
So this is the R okay.
The question did not ask for RO.
And perceive.
Yeah. And in parallel with this one as well. They all lump together. RL.
The VL is here. Not here.
VL is the voltage of the node. It's
So,
all,
so this should be a wire here.
yes.
So VL can
Yeah. Okay. Okay. Done. Okay. RL. Okay. So we don't need to do any calculation. Yeah. Here, do not forget that minus VL minus VL. Okay. Now the IL is also equal to this the current of this current generator.
okay.
IL V pi. Right. Now V pi is the voltage here. Am I right? The voltage across the resistor.
This one.
Yeah, V pi.
Goes up. Oh,
Yeah,
correct.
yeah. Goes up. Okay. So this is the V pi. Yeah, measurement from here to here. V pi. So there are two options. We can either express V pi is we can express that uh, assuming that the IB is current at the base. The current at the base is almost zero, extremely small. So literally speaking, we can consider this, we can treat this as open circuit.
So we first we imagine that this is an open circuit, and then we will
Yeah, the
go
voltage
straight.
here is V pi. Okay? So can you use the voltage divider to express V pi in terms of Vs? Now I'm going to withdraw this. Yeah, withdraw this here. Vs and then
RS.
Rs, right? I'm
Yeah,
not
yeah,
going to
RS.
Rs,
With RE.
not parallel, it's series.
Oh,
RB, and then RB is connected to the ground. So can you tell me what V pi is?
we use a voltage divider.
So V pi is
RS.
no RB divided by Rs plus RB times Vs. Am I right?
This is
Yeah.
voltage divider.
Voltage divider. This voltage divided by the total voltage. Okay? Could you just write down another line? Gm is equal to this one.
Go to this.
No. IL is equal to Gm times V pi. V pi is here. Substitute V pi in this equation. Gm RV divided by, correct? And then times Vs. Perfect. Done. Okay, I'm going to erase this diagram.
Let me take a picture.
Yeah.
Okay.
Yeah, the connection is still there, but because of the current here is too small, we can literally treat this as open circuit.
Okay.
But now we have to uh, go back to where we were. And then we just keep this on. No. You just keep it. Yeah. Now, uh, this expression is equal to IL, and this expression is also equal to IL. So do you agree that this expression is equal to this expression?
Yeah.
So can you write down this? Yeah. Minus VL also C L is equal to, yeah. Mm. Now the question, yeah, the question asks for voltage gain, mean O divided by Vs. Based on this question, do you think you can rearrange the VO divided by Vs equals to uh, minus Gm, yeah, and then the resistance here, yeah, that's right. Perfect. And do not forget the minus sign, because you have minus sign here. Okay, so now you're ready to deliver the numerical answer. You just substitute GM or BB, yeah, and then
I think we should erase some.
we can do that. But now we are now. I suggest you just do a hand calculation. Minus GM is equal to 0.04. Okay, yeah, you can do this. You will do this. Minus GM is according to the answer here. Uh, 40 milli. And RB is 10K. Uh,
Yeah.
uh,
Found or not?
R0 is 2.5K. 2.5K. Uh, RC 8K. And RL also 8K. And what was my RS is 2K. Okay, 10K. Oh, very complicated expression. I can help you. I can help you. Can you do calculation?
Yeah, I think that's
Yeah, yeah. Yeah, it should be around 2.45K. Yeah, maybe I can help you with the calculation. The answer should be 1538. Yeah, 51. Okay, let's check if the answer is correct. 51. Okay, the answer is the provider answer is no, don't worry about that. I tell you what, they calculate they treat this as an input voltage. So if you if you remove this factor, you will get the same answer. You can try this. Uh, uh, just calculate once again the V out divided by V in. We don't need the 10 ohm this factor.
Why we don't need 10 ohm?
Yeah, because the answer is based on the voltage here, not the voltage here.
Oh,
Yeah, but don't worry about that. Your answer is correct. Your answer is correct. The answer is 77 because they have no the this resistor. Uh, you can try this. I can just show you. Too. Really?
so the we in go from here.
Yeah, go from here. Yeah, go from here. Yeah, but don't worry about that.
Okay.
Don't worry about
Yeah.
that. Uh, so okay, okay, and you have already done calculation. This is 1538, and then yeah, just do another calculation. 40 minus 40 minus 40 times 1538.
How about the 2K here?
No need.
Oh, they ignore.
Yeah, because this is the actual this is the input voltage. So the question is problematic.
I don't know. Still wrong.
61
Yeah, minus 61.5.
minus 61. Yeah, almost there. Yeah. Okay. Yeah. So it's done. It's done. So your answer here is correct. Forget about the answer. I remember this part. The question for the provider answer for Park C of this question is not correct. Go. Okay. Good. You did a good job.
I should take a picture.
Yes. Yeah, this is the right answer.
Mm.
Okay, now part D of the question. Neglect R naught. This is R naught. So we try another calculation without R naught. Yeah, your answer is here. So we try this. Yeah, part. Yeah, first of all, we are dealing with
So the 8K parallel with 8K ohm.
yeah, AK and AK. We do this and see what the answer is. Okay, and then see the percentage. So
Um,
so this becomes 4K. Okay. This will become 4K, yeah?
yeah,
4K. So 4K divided by 30. What is that?
minus 1333 on 33. Yes. 233.
Okay? So percentage error. Yeah. This is the new one, and then the error. This is the Buddhist dash, right? The original value that we get is we has 51.
Minus 51.
So we try the error is equal to this one. This one. We should use which structure? Then maybe we can use this and see what happens. Let's see. What is the error? 51. They are now trying to check if you ignore the early effect, what kind of error, what kind of percentage error you get. So I think this is the one way to calculate the error. Let me check. 133 minus 51. Yeah, I think for today, we are almost done now. 1.6. 160% error. Oh, what happened?
Error. Percentage error.
Okay. No, no.
Yeah.
This one times 10 divided by 2k plus 10k is 1/40. Are you sure?
Yeah. 1/40.
1/40. And if you multiply by 4k, then you got this value, okay? Okay, I'm going to forget it now. Yeah, this is the answer we can get. The best answer we can get. So theoretically, forget about part D of the question. So we have already achieved our job. This is the standard way of calculating.
So what happened?
No, nothing.
Can I take a picture?
I know they given the
I
answer.
just want to know how to calculate the error. Okay.
Dear, yeah, how about this? Maybe 150. Yeah, check this. Yeah, this 150.
61.65.
165.
61.65.
61 is the percentage. And for the error is, really, I don't know. The voltage gain is supposed to be -8. I think I just why is so the difference is so large. The let's see, let's check if there's anything wrong here. No, I don't see anything wrong here. I know the answer for one question is not correct. This is the one. Copy. Yeah, I think it's okay. This is the right way. Okay. Uh, without early example, the answer will not be that simple. It will be A K is okay. Still okay. I think the answer is acceptable. Yeah. I will not. I will not. Still okay. Yeah. I think the answer is acceptable. Okay. So the voltage gain, the actual voltage gain should be 51.
61.
61? 51 or 61?
61.65.
Without voltage gain, without early effect or with early effect?
I take
No, no, no,
minus
no, no, no. Forget about this. What is the voltage gain? 51.
minus 51. The last voltage gain from question C is minus.
Yeah, yeah. Let's do it. Let's do it. Maybe there's some. According to what I got there, yeah, the voltage gain is 51. Yeah, you can try again. Yeah. Calculate this. Right. 2.5. Calculate this again.
Calculate this only, right?
Yeah, yeah.
Five, three, eight,
Yeah.
5, 3, 6. So the calculation is 1538.
No, no, no. The whole expression. The whole expression should be 51.
So minus 51.
Yeah. Minus 51. So this is the right answer.
Okay.
I remember well the answer for this question is incorrect.
Okay.
So much. So now we have already done this question. We thank you for your help. Uh, so
This is stop the recording.
yeah, we have to stop the recording. And if you have any questions, if the viewer of this video found any question, please leave your questions to the comment section.